Hi, this is Will.
And this is Sri.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. Hey, how's it going, Sri?
Pretty good, pretty good.
Pretty good. So, as always, what do we start off with? We start off with what are we drinking today?
All right, yeah. I have this red wine, which I almost finishing, our daily red. It says it's a vintage 2007 California red wine, which is concerning because it neither tells you the type of grape nor the specific region in California. So it kind of just tastes like a generic flavor of red wine, a caricature of red wine.
Toilet wine, I guess. Maybe they mixed it all together and resold it. But honestly,
Yep.
I wouldn't be able to tell the difference even if you did tell me which region it's from and whatnot. So I don't know about you. I am drinking more crap from Whole Foods. This time it's Focus Aid, and I guess Focus Aid is, I guess it's clean energy, essential vitamins.
Right.
It's like a low calorie dietary supplement, which I guess you're supposed to drink this if you don't want to eat food, but I ate it with my food. And so,
Does it also help with your focus, or you didn't mention that aspect at all?
yeah, I don't know, but it's not too bad. It's got a bunch of sugars, and I kind of regret picking up this thing because I'm just putting all this crap into my body that I normally wouldn't drink. And then sparkling hop tea,
Ooh, all
citrus
right.
hops, made with citrus hops, and this is zero sugar, 0 calories, so on the complete other end of the spectrum.
Very cool.
Sweet.
Getting more and more interesting every week.
Yeah, I used to not like shopping in Whole Foods because I didn't recognize any of the brands in there, but you get used to it. So, what are we talking about this week? We are talking about zero knowledge proofs. Have you heard about zero knowledge proofs before?
I don't know anything about zero knowledge proofs, and I can prove that to you.
So, hopefully, we'll just talk about what we know, and we won't make up too much stuff as we go along. So, zero knowledge proofs are a way for people to prove that they know a secret, like a password or a credit card, but without revealing the secret itself. It's kind of an odd, paradoxical thing where I say, hey, I know something. I'm not going to tell you what it is, but I can prove to you that I know it. And it's a new cryptographic primitive, relatively new. I mean, I think they started doing the theoretical work for it in the 90s, but it's starting to be used in production today, mostly in the world of cryptocurrencies. And so, usually, before people started using zero knowledge proofs, like for example, when you log into a web app, usually you type in the login and password into the web app, and that web app's centralized servers receives the password in, and then it hashes it and then checks the hash against the database of hashes for all its users.
Well,
And
if you're lucky, if you're
right,
unlucky, they just store the password.
right, like a lot of the older companies that when they have a data breach, you find out that that's what they were doing all along, which is kind of scary. And so, and with zero knowledge proofs, you don't even have to give the web app your password to authenticate. All you have to do is offer up the proof that you have the secret, and then they would be able to authenticate you and authorize you to access the app that way. And so that's kind of it in short. Is that what you found in your research and when you were looking into this?
Yeah, I think there were a lot of different examples for zero knowledge proofs that I'd seen. A lot of sort of toy cryptographic stories. Yeah, so from what I learned about zero knowledge proofs is that there are two parties that are trying to collaborate in some way or vet each other. So a lot of the explanations of zero knowledge proofs have these toy examples where you have two parties One party is called the prover, who is trying to prove something, and the other party is called a verifier. And they give them cute names, like sometimes they're called Peggy and Victor and things like that. But basically, you have these two parties that are trying to show each other that they have some shared knowledge. For example, that they both know a password to get into a club or something, or they're trying to arrive upon a shared knowledge. So, for example, one toy example that I'd seen was where two people are trying to prove to each other that they have the same amount of money or the same number of pieces of Halloween candy without revealing to each other exactly how much money or candy that they have. And so basically that's the gist that I got.
What in the example, why would both parties need to verify that they got the same amount of money? Was it just like a toy example, or was it like inspired by some sort of real world scenario?
Yeah, I think a lot of it was just a toy example,
Okay.
but I could imagine that you could use it in the case of, for example, two companies that were vetting each other for an acquisition or something, and they wanted to show that they had the same amount of cash on their balance sheet or something like that. It seems a little contrived, but I think that that's the case with most toy examples, that they just want to show a proof of concept. Obviously, the real world scenarios are going to be much more complex.
Let's see. Yeah, so I guess zero knowledge proofs are definitely new, and they're currently being deployed in production for scaling blockchains, which we'll get to later. But I did want to go back to a little bit about how zero knowledge proofs works, because fundamentally it seems like there's this paradox, like how do you show that you know something without giving it away, right? And the New York Times actually had a good layperson's description of what the zero knowledge proof algorithm is doing. And so I'll just lift a page from their example. So let's say I am the prover and you're the verifier, and I'm saying that, okay, I know the path from Times Square in New York to Shea Stadium, but I don't want to give that away to you from the get-go. So what we'll do is we'll have a series of interactions. So unlike most other cryptographic algorithms where it's a one and done sort of situation between the prover and the verifier, zero knowledge proofs are interactive, where you and I go through multiple rounds. So the first round, I would choose a point midway between Times Square and Shea Stadium and then show you that. And so you can say, okay, what is the chance that Will is lying to me, given that he picked a point that's kind of seems like it's halfway. And then since I gave you a point midway, you can say, okay, for the second round, then give me a point quarter of the way or 3/4 of the way, right? Mm-hmm. And so we iteratively bisect until you're satisfied that the chance of me lying to you about the fact that I know the path from Times Square to Shea Stadium is effectively zero, right? Because mm-hmm. at some point, if I don't know it, I'm going to screw up.
Yeah. In that example, does the verifier happen to know the actual path?
No. So this is kind of more of it's a layman's analogy, because there's a couple things that aren't quite right with it. Because in this example, when I give you the halfway points in the path, you can effectively reconstruct the solution yourself. In the actual problems that are given in zero knowledge proofs, it's not something that you can reconstruct. So instead of the path between Times Square to Shea Stadium, the prover picks NP complete problems. such as the three colored graph problem. And so for those of you unfamiliar with it, graphs are nodes connected by edges. And it's a well-known computer science problem where given any graph, like how do you color each of the nodes with one of three given colors, say red, blue, and yellow, so that no two adjacent nodes would have the same color. And so it's very easy to construct a graph with this condition, but it's very hard to be given a graph and then color in those nodes. And so it's in a sense a one, just like there are one-way cryptographic caches, this is similar to a one-way problem where it's really easy to construct the solution, but it's really hard to kind of fake it. And so given this, like unlike the example of the path from Times Square to Shea Stadium, me as the prover can randomize my solution every time that you're verifying it, so that there's actually no information that you carry from round to round. And so that's the zero knowledge aspect of the proof. And so you don't come away with any more knowledge about how I can construct something, even though you've guessed multiple rounds.
Got it. So let me just take a step back and try to build on my understanding. So in problems that are NP complete, the interesting thing about them, like you're saying, is that solving the problem from scratch is actually really, really hard. It's computationally intensive. You have to do a lot of work to do it. Now, given
it's not just a matter of having big computers. It's some of them are given a big enough problem size, it would take longer than the time the universe has been around to figure out a solution, an optimal solution at least, right?
Right. So the scaling, as the problem scales, it becomes not just harder to solve in polynomial time, it actually explodes in the complexity to solve the problem.
Right.
Now, the interesting property of these is that assuming you have a solution, you can give it to somebody who can verify that it is a solution to the problem. It meets all the constraints. For example, in the graph crawling problem, that no two nodes that are connected by an edge share a color, and that there are at most three colors being used to color the graph. So they can verify that, and they can verify that in polynomial time. So meaning that even though it took a lot of work to solve the problem, it doesn't take as much work in the size of the problem to verify that the solution was correct. So that's the standard sort of one-way problems.
Yeah.
And so you see this in for example, even file hashing is a one-way function where you can verify the hash of a file, but it's very hard to guess to go from the hash of the file back to its original contents. So zero knowledge proofs are kind of an extension of this, in that what you're trying to do is avoid leaking to the verifier the solution to the problem itself. So if you wanted somebody to verify an NP complete problem, normally you would give them your solution and you would say, hey, I've solved this problem. Check that I have solved this problem. In a zero knowledge proof, what you don't want to do is give them the solution to the problem, maybe because they haven't paid you money for the solution yet, or maybe because the solution itself contains private information which you don't want to divulge to them. And zero knowledge proofs allow them to verify, okay, you have solved this problem to some degree of confidence, and in the process they can't come away with whatever information you were trying to hide.
Yeah. And to clarify on the interactive part, when I give you a graph, the nodes of the graph and their colors are all hidden, and you only pick two adjacent nodes to reveal. And so that's an even easier check than checking the entire graph. You can check like any two adjacent nodes, and if they have different colors, then it increases the probability that I know the solution to this problem, right? But if they're ever the same, then you know that, oh, okay, like he was just faking it all along.
Mm-hmm.
And so every iteration, there's a new set, like a new graph for you to check the colors on, and that's where the zero knowledge part of the zero knowledge proof comes from. And so I thought that was pretty interesting in that it's a departure from the usual cryptographic primitives where there's this iterative aspect to it. And the iterative aspect is also pretty interesting in that the transcript of us doing the verification, you couldn't take it to somebody else and say, hey, like this was a transcript, because the transcript itself could be faked. It's only if you had the interaction yourself that you can verify that it was true. So it's not like you can take that transcript and give it to somebody else and they would be able to unequivocally believe you that I have the solution. Like everybody has to interact with me in order to do it. Does that make sense? So
Mm-hmm.
it's not like you can take your interaction and then use it to fake it with other people, right?
Yeah, got it. Yeah, that makes sense. So actually, in my research, I came across maybe some variants where there were some variations of this protocol which were interactive, and some where you actually generated a proof which you could drop out onto some public ledger, and then anybody could come across later and verify it.
Yeah.
So I think there are actually a lot of different twists to this basic premise, but at its core, yeah, I get what you're saying, where you basically want to prove something, and you do it in a way that doesn't leak what you know to the person who's verifying it at all.
Are you referencing like the ZK Starks and ZK Snarks stuff, or were you referencing something else?
Yeah, I think.
Okay.
Yeah,
we can get to that as we go along in the podcast. Cool. So I thought this was really interesting because I guess a near-term problem to most people, maybe not near term, a problem close to everyday people are the recent data breaches in these last 5 to 10 years or so. It didn't used to be the case that you would hear about data breaches at gigantic companies, but now it happens like monthly, I want to say, if not weekly. And there's a variety of different reasons for this, which I guess we won't get into. But one of the issues is that for a centralized authority or a web server, in order to authenticate users, they would have to know these passwords, or at least hashes of passwords, in order to authenticate people. And when they get compromised as a single source of truth, then that's where the data leak happens. And with zero knowledge proofs, it has the potential for that information, the passwords, to live at the edges and effectively be decentralized, but people can still prove who they are. And so that should make it much more difficult for these sort of data breaches to occur in the large. Of course, single people can probably still be social engineered and hacked, but at least you won't get these massive breaches of millions of accounts that are compromised, right?
Mm-hmm. Yeah. I actually think that there's an added advantage to zero knowledge proofs in this authentication aspect. So if you simply wanted to prove that you are someone without having somebody store your password and hash it, you could use public key cryptography. So you can say that I am this person who has this public private key pair, and send me a message that you want me to encrypt or to sign, and I will sign it, and you can verify that it was me who signed it using my private key, as long as you know my public key. But one use case that I've heard for zero knowledge proofs in the case of authentication and authorization is that you might not actually want to reveal specifically who you are to the service. You just want to say that I am one of N people who is allowed to do this action, and you don't get to know who I am. So I actually don't know offhand what kind of nefarious or secretive use cases where you don't want a web service to know exactly who you are, but you simply want to take an action as long as you're part of a whitelist. But I think that's one advantage on top of public key cryptography that ZKPs provide.
Yeah, and as regulations might get more stringent, companies may not want all that data about their customers if they don't need it, so that they don't have to deal with subpoenas. I mean, maybe some of the bigger companies can have teams of people that can handle sorting through these sort of regulations because they need it for advertising or some sort of like business intelligence. But increasingly, maybe if you can get away with not knowing it, then you don't have to. So you don't have to keep up the expense of holding this sort of user data. That might be a reason why companies might want to do this.
Totally, yeah. I think in the last couple of years with GDPR specifically out of the European Union, data has gone from being an asset that companies want to collect and mine to being increasingly a liability that you don't want to store in your systems, or you want to get it off your hands as quickly as possible. And so it does make sense that there are trends towards avoiding the centralized collection of data. And I do actually take back what I said about the nefarious purposes. There are many situations, even just in real life, regular life that we're aware of, where you don't want to leak your identity or have it associated with an action, even though that action is not necessarily itself negative or nefarious. So a big one that comes to mind is voting. You want to be able to vote for someone and not be able to have your vote be traced and leaked for fear of repercussion. At the same time, you might want to prove that you voted at all to someone if they ask. And so there are cases like that where you want to take an action, but you don't want your name or your identity to be associated with that action. Yeah, because there are consequences to having that be traced back to you.
Yeah, actually, also, like, there are instances where you may not even want to. You want to be sure that your vote counted, and so, but you may not want people to be able to prove or be able to figure out that you voted, because then you would never be able to sell your vote, right?
Yep.
And so these sort of cryptographic primitives, I think, are useful for things like voting, although I think it'll be a long time before people are used to it or understand it, because it's the UX for cryptography is just terrible. Not just the name of things, but just like being able to use it. Like, people might have used public key cryptography if it was a lot easier to use, but as it stands right now, some of this stuff needs like designers and UX people to get a handle on it for it to be more widespread. But definitely for now, on the side of, okay, let's just use paper ballots and stuff like that as like a main thing. But I hear you for things like electronic voting, not even for government, but like for DAOs and whatnot. Like, there's advantages to not showing what your vote was, but knowing that your vote counted, right?
Yeah, totally. I could see this being applied as is for DAOs. Obviously, the population of people who are participating in DAOs are to some extent sophisticated technically. And so Yeah, and I'm sure that DAOs, as they mature, are going to want to maintain some amount of privacy or discretion or in their affairs. Right now, DAOs are completely open by default. Everybody can look at their books, everyone can look at every vote that has ever occurred, and that's a huge advantage. But as DAOs become more specialized, there are obviously sectors and verticals of life where more discretion is needed, especially when it comes to finance, when it comes to medical decisions, credit, things like that, where it doesn't make sense to have a DAO be completely open to everyone. And so I'm sure that zero knowledge proofs will be a core technology that allows certain aspects of a DAO to be run on the blockchain in public while providing some amount of privacy to the participants.
Mm-hmm. Yeah. So then, are there other applications you were seeing? Because other than that, like the near-term thing, I was gonna end up jumping to stuff inside of crypto. And so, were there other things besides voting that you saw as applications of zero knowledge proof today?
Yeah, outside of crypto, you mean?
Just in case, covering our bases before we jump fully into your favorite topic, crypto, right? Only on this podcast.
Yeah. No, outside of crypto, I think all I've seen are toy examples.
Yeah, like this is relatively new. If it wasn't for crypto, I probably wouldn't have heard about this sort of stuff either. Yeah, so like where I saw a lot of the literature on zero knowledge proofs came from people's attempts to scale the Ethereum blockchain. And so, as our listeners might know, Ethereum is currently the second biggest cryptocurrency in terms of market cap, I believe. And it has a system where you can program smart contracts on it. And so, one of the limiting factors of the Ethereum blockchain is the number of transactions per second that it can provide due to the way it was designed off of proof of work. But even if when it moves to proof of stake, it increases the transactions per second a good amount, but it's still not where people want it to be. And so one of the ways that people have tried to scale the Ethereum blockchain are what they term the L2 or level 2 blockchain solutions. And there are a number of them, from state channels to what they call plasma and the optimistic rollups, using some of these technologies using zero knowledge proofs. And so to outline how zero knowledge proofs fit into scaling Ethereum blockchain, effectively a project, they start running their own blockchain called a side chain. And instead of using proof of work miners, they use validators that use some other proving scheme, such as proof of authority or or proof of stake itself, right? And that's definitely a little less secure in terms of the decentralization necessary to maintain it. But what it gives you is an increase in transactions per second. And what's different here is you can take a batch of transactions on this side chain, and you can roll it up into a single transaction and then prove to the main Ethereum chain that these transactions happened. So you would do the transactions on the side chain, and then all the transactions would get batched up and the proof would be generated for it. And then that proof is then checked by the main chain as the verifier. And then once it's verified, you would write that, and then all the batch transactions would settle on the chain that way. And so this is how some of these L2 scaling solutions are working. And some of them are some of the names of the projects escape me right now. I think it's like Polkadot, if not mistaken, as well as others. And Polygon, I think, but don't quote me on that because I haven't used some of these, and so if I'm wrong, I guess we'll correct it in the show notes.
Okay, I mean, I have a question about this. So
Yeah.
I understand the advantage of basically not clogging up the main chain with, small transactions that you want to happen quickly, and so you kind of batch them up and you send them over to the main chain only when you want, them to be basically immortalized. But in this case, does zero knowledge proofs mean that somebody who's looking at the main chain will also be unaware of or unable to trace back like exactly who transferred what to whom? Does it provide that kind of privacy?
My understanding is you would need to go to the side chain to look at the history because like all of that is rolled up, and so that's my understanding. Yeah, like if the side chain went away, you would just see that there was proof that it happened and it happened correctly, but you couldn't tell exactly what happened because it's zero knowledge, presumably, right?
Okay, so that's interesting in that let's say that I'm a very large company. I have a variety of bank accounts, or okay, let's go back to crypto. I am a very large DAO and I have a variety of wallets, and I'm trying to make a transaction happen. Let's say that I'm going to purchase another DAO or something like that,
Yeah.
or I'm going to make an investment in some NFT or some whatever, and I don't want anybody to know what I'm doing. And so it sounds like it's possible that I can have a side chain. Maybe I run on some side chain that's publicly available, or it's presumably possible that I can maintain my own private side chain, and I can move the tokens or a cryptocurrency between my wallets that I control, and just submit a proof to the main chain saying, well, all of this movement actually happened, without anybody being able to know exactly what my wallets are or how much money I've moved. All that's known to the main chain is that, okay, these things actually happened, and the state of the world is correct in that the money that was debited from one wallet is credited to the other wallet, without anybody being able to come back and say, okay, I know you control all these wallets, and I know that you're trying to amass this amount of capital. You must be making a big purchase, and somehow being able to preempt me.
Sounds like it. I mean, from my understanding, probably. Although today you probably just not need to run your own sidechain. A lot of times there are privacy chains like Zcash or Grin, where people use an exchange to move that money into these privacy coins, and then with the privacy coins you can just transfer that money around and nobody really knows the amounts or to where, and then they pull it back out again through the exchange. I guess that's one way to do it.
Okay. Yeah, that makes sense. So from my cursory reading about Zcash, they also use zero knowledge proofs.
Maybe hence the Z, like Zcash stands for zero knowledge proofs, not zombie cash. So
yeah. Okay, cool. So this is an interesting concept. Just in general, the idea that you're able to perform some actions on off chain, or basically on a separate chain, and then be able to submit it back to the main chain. And maybe you're doing it for privacy reasons. Maybe you're just doing it to avoid clogging up the main chain.
Yeah.
But basically the key that it relies on is the fact that you're able to prove to the main chain that something actually happened.
And it happened correctly. Right, without the main chain having to redo that computation to verify that the answer that you're giving it is correct.
Interesting. Yeah, so that's pretty interesting just in general. I mean, I wonder, outside of just the privacy aspect, I have heard of things like just the transaction speed of Ethereum being limited in some sense. And if I had, let's say, an economy in my like MMORPG, it has a whole virtual world, it has an economy, it has a crafting economy, maybe things can be mined from resources, whatever, right? Like I want to have my users in my MMO actually be able to transact in a decentralized way. It's potentially possible that people could basically do all of these actions on my side chain and then have those verifications being submitted back to the main blockchain. So maybe they buy my game's virtual currency and they're able to transact with each other in a completely decentralized way, provided I give them a side chain. And then they're able to, and my side chain basically submits proofs back to the main chain, the main Ethereum blockchain, saying that, well, all of these balances have been properly transacted.
Yeah.
And so if they wanted to cash out and turn their, gold or whatever back into real, Ethereum, then they would be able to do so because there's some guarantee that what was going on the side chain was actually correct.
Right. Right. And the side chain has to effectively commit the balances to the Ethereum main chain so that you can, I guess, take those account balances and convert them to any other ERC20 token. ERC20 is just a way to say a cryptocurrency based on the Ethereum blockchain. Yes, and so that's correct. And there are a variety of different flavors of cryptocurrency blockchains. And part of it is because they're playing around in the design space and turning different parameters and knobs. And one of the things they play around with is how decentralized do we really need it? And it seems like the blockchains that gamers and gaming companies are flocking to are the ones that don't need nearly as much decentralization, but they want the transactions per second. And so right now, some of them are just like blockchains on their own, such as Solana, EOS. Those are less decentralized, but people still use them. And so mainly for gaming, and presumably because people don't think of game assets as being financial assets that you need to secure, but maybe that'll change in the near future as play to earn becomes more and more prevalent. Mm-hmm. So yes, that's true. I don't know of any small independent gaming studio that would try to run their own side chain, and so maybe like a larger gaming studio would do that. And so I'm not sure why they might write into the Ethereum main chain if they have the resources to do so, but maybe because their users clamor for it and they want to be able to convert to ETH, or they could like rely on an exchange. But I think the point I'm trying to make is that normally for any game studio, writing an MMORPG is a gigantic undertaking.
Yeah, right.
But not even an MMORPG, but like having a marketplace is a giant undertaking. But now with like cryptocurrencies, you get that for free. It's something that you don't need to build, and users will just be able to use. You just have to build the interfaces and the digital assets for it, and that sort of stuff comes in for free. Now, whether that's good for your game or not, that's up for you to design. But those are just new building blocks for you to use for other gaming experiences, such as play to earn nowadays.
Yeah, it's a good point that not every individual game is going to go build its side chain. But what you're saying makes sense in that there might be a sidechain network that is tailored towards gaming, which allows these types of transactions to happen. And the advantage is actually that the main chain in Ethereum is this completely decentralized, trustless environment.
Mm-hmm.
And so that adds a lot of computational complexity in terms of verifying that things have actually happened and committing them to the chain. And so that puts a cap on the amount of transactions that can happen. Now, what you might want to happen is that you're in your domain, your problem domain, let's say in the case of gaming, does not require that level of decentralization, and it does not require that level of like lack of trust between parties.
Yeah, maybe not. That's something that people are still exploring, but I think the general feeling people have is that it doesn't, and so that's why they're flocking to these sort of solutions. But yeah,
right.
Go on.
Yeah, so basically what this allows you to do, what maybe zero knowledge proofs allow you to do, is to say that for my problem domain, I don't need this level of decentralization. I can get by with some lesser amount of decentralization. And so I'm going to use a side chain that provides me the characteristics that I want. And then I can make use of that and reap all the benefits. But at the same time, if I want some cross compatibility, again, I want maybe people to buy into my ecosystem using ETH, or cash out of my ecosystem into ETH.
Right.
You would need some amount of basically verification that the transactions that are happening are sound, right? Like that, things are being transacted properly. And so I can even imagine in the case of gaming, you can get by with a centralization and maybe parties can trust each other a little bit more. You can potentially even, I'm thinking of completely untrusted or completely trusted environments where you have established, let's say, companies that happen to have crypto assets. And so you have a company A, Google, and then company B, Facebook, and somehow for some reason they find themselves in possession of crypto assets and they want to exchange them with each other. And so in that case, if you have two very, very established companies, you don't need to go through the main chain. You can actually commit some transaction on a maybe very trusted network or trusted private chain that does not require any decentralization and is in fact just backed by lawyers and the legal system.
Yeah, the reductive version of a blockchain is a database, right? So and so like as you get more and more trusted participants in the chain, effectively you need less and less of what a blockchain design offers, and effectively it reduces to a database. And so if you were a single company, I would see the reason to build a sidechain is the same reason that companies would build a platform, because they want to be able to reap the benefits and control over the ecosystem because it's strategic for them. And so the reason that you would have something like this is so that multiple gaming companies can be on the gaming side chain. Like it wouldn't make a lot of sense for a single company to build a side chain for itself, because that's a lot of work. You just build a database, right? And then just commit those transactions to the main chain that way. So, but yeah, I think what you're saying is what you're saying makes sense. As you reduce the number of untrusted participants, like you could effectively just transact between them and also just in a single database. But I think the difference here is that when you have multiple participants, trusted or not, on a blockchain with standardized contract interfaces, you don't need the APIs anymore, because it's effectively like a narrow waist for these digital assets. Right now, with the way it works, you have n by n connections between services, and you need to do the API connection between each of them. And so if you had standardized digital asset file formats or digital formats, effectively, just like ERC20 for cryptocurrency tokens and ERC 721 for the NFTs, then that's effectively a common interface for anybody to integrate against. And so you get this proliferation of an ecosystem that a lot of people can benefit from without the burden of that n by n connection. Every time there's like a new service, you need to find a new way to read its API documentation and throw a bunch of developers on it.
Yeah, that makes sense. People are not going to be creating sidechains willy-nilly. One use case actually that I had heard is for zero knowledge proofs in the case of sidechains is cases where there are compliance requirements. So for example, if Venmo actually supports cryptocurrency and they wanted to have their users trade cryptocurrency or send each other cryptocurrency between themselves, the regulations on Venmo are that they must verify the people who are on their platform. So there are these know your customer laws,
right?
In the United
what
States.
People call KYC.
Yeah, exactly. Yeah. So in that case, Venmo might not want to run those transactions on the main chain where they just take a arbitrary wallet address and allow you to send it to anybody, because then they're on the hook if you sent it to some drug dealer or some terrorist organization or whatever. And so one use case that I'd heard in my research is that they might want to actually run these transactions off chain, maybe on their own chain, where they can verify that the participants on that chain have gone through the KYC process. And then, and only then, once they've verified that and perform those transactions, then commit it back to the main chain to prove that the money has actually transferred.
I see. Yeah, it's a way to control the wild west of crypto that is right now, where you can just kind of send money most anywhere, which I think a lot of the crypto maximalists really like. But it feels similar to the sentiment of the internet in the early days, where the rallying cry was information wants to be free. And, there's a lot of, it's not a bad thing. That's how we get a lot of free stuff to read in the last couple decades. But the internet today is very different than the ethos of the internet in the 90s. And I suspect the similar thing will play itself out in cryptocurrencies as well, where you have a lot of ideologues, people with ideologies.
Yeah.
But KYC probably will rear its head somehow, and I would be surprised if using the scheme that you described will also be another way to do that.
Yeah, I think as I think about this, we're talking about DAOs, we're talking about transactions and KYC. Basically, right now, the vision of crypto is that anything is possible and everything is open by default. And so I think this is great because it's such a pendulum swing away from the way that things are run nowadays. And there's obviously a lot of energy around it. But as more and more of these use cases become formalized and more serious business gets done using these technologies, there's going to be a need to bring privacy and regulation back into the mix.
I think that's part and parcel where when people start applying it to things that to different domains, they find that they need to turn different knobs in the design space in order to fit their problem domain, similar to how people have found ways to do that in the internet. And so that's effectively where you're trying to go with this, right?
Yeah, totally. So I think that, for example, if eventually the medical industry starts to use the blockchain, for example, to run an insurance scheme. So you can have a DAO that provides insurance payouts to its members or something like that.
Yeah.
You would want to have a lot of this information private. So if I want to make an insurance claim against my insurance DAO, I don't want to submit a claim in the form of a DAO proposal or whatever saying, well, I have this disease and I had this treatment and please pay me this amount of money, and have the DAO commit publicly like, okay, we will pay you your claim for erectile dysfunction, you know, and then everybody can go and see like, well, okay, this guy now has erectile dysfunction. And so I think you would want to use tools like zero knowledge proof to obscure the details of the nature of the transaction, while still actually being able to facilitate the transaction on the public chain. And there are tons of use cases for that. And so, yeah, I see that as we take this technology from this completely virtual world of, I mean, to be realistic, very little consequence, very little sensitivity, to domains where people's lives are at stake, people's health is at stake, people's privacy is at stake. You would want to start to allow people to tune the knobs to make things less open by default when necessary.
Yeah. I mean, I don't have much to add to that. I agree. And I think it's just like I mentioned earlier, reasoning by analogy with the trajectory that we've seen on the internet, where I remember social networks were open by default. People overshared to a large degree, where oftentimes you're saying TMI. So this is the TMI turkey. I don't know if you've seen that, but anyways, yeah, overshare. And now I think people have kind of gotten used to it and understand what is at stake when they do share things, because they've heard they've seen what's happened to their friends and the horror stories that get played up in the media. And so I think people will see the same sort of thing in crypto as well. So, but yeah. And so like, given that, then I can see, especially for DAOs, like there's things that the DAO would want to prove that they own, but they may not want to divulge that information to everybody. And so using zero knowledge proof may be a way to kind of hold that information. Of course, the details are a little bit hand wavy in my mind as to exactly how that happens, and I need to look into that. But the general idea for zero knowledge proofs is that there's a computation, whether it's verifying transactions and balances or something else, but there's a computation that I want to do, and I want to prove to somebody else that that was done correctly without them having to do it. And so when we were thinking about some of the second and third order effects of this, I was thinking that maybe it's possible for a decentralized AWS, although I think that's actually pretty far off. And so a decentralized AWS is where you would have a fleet of anybody running nodes that can run servers for other people, but then the network can verify that you did the computation correctly, like you responded to every request correctly as was intended by the person whose code wants to be run. But we're actually pretty far from that. There is a limitation to the types of computation that zero knowledge proof based computation verification can support. And so these technologies run under the names of ZK snarks and ZK starks. They're like different flavors of using zero knowledge proof to say that this is a computation that I did it correctly. You don't have to do the computation. I could just prove it to you. And so the computations that can be done right now and verified are actually relatively simple because like the computation has to be converted into like an arithmetic circuit, and then there's a bunch of steps that have to happen, and then you can write a smart contract that then does verifications, but it's not like you can verify even something as simple as a web server is correct. Right now it's just mostly like arithmetic sort of computations that people are verifying, which is a good fit for like financial stuff, right? But it's not currently not any more complex than that.
Okay, so allow me to wave my hands wildly, like just while I speak, pretend that I'm flailing my arms.
Right.
So I was looking into quantum computing the other day, and the interesting thing about quantum computing is that quantum computers require that you're able to reduce your problem again back down to what's effectively like a system of equations, just like some type of probabilistic system of equations. And I can imagine that rather than verifying securely, arbitrary, boring computation that you would run on AWS, what if you had a fleet of quantum computers? And quantum computing is obviously very expensive. And so what the people who are running the quantum computers want guarantees on is that they don't do a bunch of work and then don't get paid for it. But what the person who is submitting the workload to the quantum computers wants guarantees on is that the person with the quantum computer didn't just fake their way to the solution and providing some like stupid solution that they have no way of, again, recomputing and being able to verify. And so I can imagine that zero knowledge proofs are actually a realistic way to solve this kind of deadlock scenario.
It sounds like a good fit, like based on what little I've read about. I mean, like I've read a fair amount, but like I wouldn't call myself an expert. But like given the outline of the problem, it seems like it's a great fit. And strangely enough, I don't know if these cryptographic hashes on the chain could be broken by quantum computers or not. I don't know enough about crypto to do that, but if they could be, then the entire history, I guess, could be read even if it was hidden. So I don't know. That's like a strange loop-de-loop. But yeah, that's kind of interesting. But yeah, it seems like it's a really good fit for the problem. Like if any of our viewers or listeners, future or current otherwise, like know something about this, let us know.
I think you bring up an interesting direction, which is to what extent are these proofs protected against quantum computing? So, we have some guarantees on zero knowledge proofs, but does that assume that you don't have access to quantum computing? And then at the same time, I think going back to what I was saying, what is the intersection of problems which can be represented as zero knowledge proofs and at the same time also be represented as quantum computing problems, right? So I think that quantum computers can solve graph problems, and it sounds like zero knowledge proofs can also capture proofs of solutions to graph problems, at least the three coloring problem.
Yeah.
And I'm curious, just what is the Venn diagram of things that are able to be computed by quantum computer, and then things that are that you're able to generate zero knowledge proofs for, and how big is that overlap? And then in that overlap, are there actually interesting problems that people would want to solve?
Presumably, like any NP complete problem can be converted to any other one. If you can find a path to one of them, you can find a path to all of them.
Yes. All right. So three coloring of a graph is NP complete, and so presumably all NP complete problems are able to be
like
zero knowledge verified.
I think as long as you can find a conversion to a known one, then you should be able to find one. That's my understanding, at least.
All right, cool. I'll believe it. I am just a simple working programmer.
So. Right. Aren't we all? Aren't we all? Yeah. So then, like where else do you think, like, if zero knowledge proofs were pervasive, like where else do you think it would be applied? Or like, given that this thing exists, like what other things would people be able to do that they wouldn't be able to do today, or they would do differently?
Okay, so this might be controversial enough that we should cut the entire section. But
Sure.
one thing that I was thinking about is that there are a lot of barriers to collective action that are barriers because initiating the collective action would require a whistleblower to reveal that they knew something. And in revealing that they knew something, they take on personal risk.
Mm.
And so I'll give you an example, and this is going to be controversial. So in the case of the Me Too scandal, which is where, it turns out that the world of Hollywood and many other industries is full of criminals.
Predatory males. Yeah.
Yes. So in that case, it was known to all the victims, of the crimes, who the perpetrators were. But what it took was a critical mass of people for any individual to be able to feel comfortable revealing that, hey, Harvey Weinstein specifically, or Weinstein or whatever,
Yeah.
is a creep.
Yeah.
Right? Because if I'm the only person in the world who knows that, then it's bad news for me. Harvey Weinstein's going to send his goons.
Right.
I'm done for.
Yeah.
Right? But if 100 people all know this secret, then we're all collectively safe. Now, the problem is that it took a trusted third party. I forget who kind of leaked the news first, or spread the news first.
Right.
But it took a trusted third party to sort of collect enough critical mass for them to actually break the news and say, hey, it turns out all these 100 people have all confidentially named to me Harvey Weinstein did something bad to them.
Right.
And so in the case of zero knowledge proofs, I don't know how exactly you'd formulate it in this framework, but it's possible that you can reveal to the world, hey, I have the name of a person who is a creep and a criminal, and everybody else could also generate a similar proof. And maybe by being able to verify these proofs, you're able to say, hey, I think that this person has named the same person that I have, and all of these 100 people have all named the same person that I have in mind. And so we now have critical mass to go and out this person.
But then that means the verifier would have to go to each individual person with an answer already in mind. No, wait, they don't have to have an answer. They just have. How would you match the proofs of two different individuals, like two different provers?
This goes back to the, do we have the same Halloween candy, pieces of Halloween candy example, right? So in that case, I know how much money I have, you know how much money you have, and we're able to somehow verify that, like, either we have named the same number of pieces, or if in the case of a failure, all we know is that, okay, we did not agree on the answer. And so you can generalize that not to pieces of Halloween candy numbers, but you can generalize that to names. And so let's say that I have a list of 1,000 names of potential people who I could name in Hollywood, let's say, just all the Hollywood directors. Right. And I say, I picked this person and who I want to name, and then you pick somebody who you want to name. And then we come out of that transaction either saying, oh, it turns out that we named the same person, or in the case that we didn't name the same person, neither of us knows who each other had in mind.
Right. Even if we name the same, well, I guess if we name the same person, we would have to switch roles, right? We'd have to switch the role of prover and verifier using the same thing
Yes. So in the case of the Halloween candy example, I believe the property is that both parties in the same proof mechanism are able to know the outcome of the proof. So it's symmetric. Both people are both the prover and the verifier of each other.
Right. Yeah, I don't know how that would be realized in an actual product, or like maybe like the legal thing uses it, but I get what
Yeah.
you're saying in that it's almost like a, not to make light of it, it's kind of like a Groupon for outing creeps. I mean, but maybe that's the it's gives the wrong flavor. It's I guess this is the controversial segment of the thing, so it's not just
We're
you.
gonna keep it. We're gonna keep
Right. So
it.
so but basically like Groupon, Kickstarter, but the idea is collective action, so that like once you know there is a uh, critical mass of people moving in the same direction, then you feel safe in numbers to herd. I suppose. Yeah, that's
Yeah.
pretty interesting. And so if that's the case, I wonder if there would be more collective action, or like bottoms up movements that would
Mhm.
happen as a result, because currently it takes a while for those things to surface. Have you ever seen that video where the guy's dancing by himself on some hilly grassy knoll with a
And
whole
then
bunch of picnic?
eventually,
Yeah,
yeah,
like a second person joins them,
yeah,
and it takes a while, but then like once a third person joins, like it snowballs pretty quickly into a dance party. And whereas before it was just like one dude dancing by himself looking kind of foolish. But I think the mechanism today to move people to collective action is through media and a lot of the cultural sensibilities of people, I suppose. Like before it was like TV where you had like a central broadcaster, but now with the web, everybody's a broadcaster, and
hmm
the clips are shorter and shorter, and we have like algorithmic feeds to help amplify those things. And so that's the mechanism we rely on to get the sense that everybody's moving in a particular direction, or to enable a change of sorts. And so I guess if zero knowledge proofs could be packaged in this way, then that would be an interesting way to get more and more like grassroots movements to enable the change that people would like to see, perhaps for better or for worse, right? So
hmm yeah,
there are many different types of people out there with many different kinds of wishes, and I guess there would be more and more of that. And I think in some sense it's good because there people like to see change happen quickly. But on another hand, I guess the reason why change happens slowly is that democracy takes compromise, and compromise always takes time, right? And so if you
yeah,
have a lot of these different factions, I can see more chaos happening. I guess as we've surmised in our episode on the DAO, is that we'll have more chaos before things settle down.
yeah,
Anyways, so that would lead to an interesting future, actually.
yeah. So there's this concept that you might have heard of called the Overton window, and basically it's this sociological concept of the Overton window specifies the range of ideas that are safe to express in a
Mhm.
society,
Yeah,
right? And if once you're outside of the Overton window, people cringe, people, you're not allowed to say those kind of
yeah,
things.
bristle at it.
Yeah, and so at the same time, there are sort of secrets that people have in their heart that are outside of the Overton window. Obviously, when I say this, people are going to start thinking of like racism, sexism, all this kind of thing.
Oh, I
But
would
at
thought you
this,
were gonna say like kinks, but yes, that
yeah,
that too.
yeah. But at the same time, there are things that people believe, but people don't divulge because they don't know to what extent other people are okay with it.
Yeah.
And so I see that it's possible that you can sort of expand the Overton window when appropriate, because there are probably things that everybody has in mind, or many people have in mind, that they want to see come to fruition in the world. Like you're saying, in the case of grassroots political movements, actually a really good example is look at the way that the tides have turned in the case of legalizing marijuana. Like, it's not like everybody suddenly in the last 5 or 10 years changed their mind on like whether marijuana was a good or bad thing. Most people were just like apathetic to marijuana, apathetic to supportive of people smoking weed.
Yeah.
It's just that nobody in the 90s came out and said it, because if they did, then they would be the one weird pot smoking person among the group.
Besides, there were too many videos of pot smokers jumping out of windows.
Right.
It's, for those of you that don't know, it's an old like 80s clip of like the dangers of drug use and marijuana, and somebody smoked weed and then jumped out a window. So
yeah. So yeah, there was a lot of fear campaigns. But at this time, in the present moment, the Overton window has shifted to the point where you can probably, in most reasonable scenarios, mention weed, maybe even mention that you support the consumption of weed. And so, but it took a long time to get there. It took a really, really long time to get there, right? And I think in the future, as we get to DAOs and grassroots movements where there's going to be this explosion of the diversity of viewpoints, the diversity of actions that people want to take, and potentially even the fracturing of the two-party governance system that we have to allow for a variety of political views. I could see that you could use these kinds of things like zero knowledge proof to basically express your support for some idea without divulging necessarily that you personally support it. And maybe we're able to get to a consensus faster and be able to accelerate our collective action towards something which would otherwise be very controversial and hush hush.
I wonder if this could be done in real time, because there's always those science fiction movies where people are walking by each other on the street and then their phones get dinged if there's like a love match or something like that. So you could conceivably have a ding where like somebody shares your belief that's outside the Overton window in the political sense, but I guess something like that. It's a way to gather moss on the rolling stone as you're moving about in the world, if that makes any sense.
Yeah, no, I mean, actually, I was thinking of the sort of the middle school scenario where you like someone and maybe your crush likes you, but like you don't want to tell each other that you like each other, so you use zero knowledge proofs and cryptography to divulge that you're interested in each other. That's definitely a thing that's going to happen.
Because usually with, as you can tell with your research into zero knowledge proofs, like a lot of times things of cryptography, there's like some scenario that's made up and then they'll just invent like a completely hard cryptographic solution to solve that like common everyday problem. Do you like me? Yes, no. But we can't divulge that, right? Yeah. That seems to be par for course there. But no, I think there is some variation of their thing that makes sense there. Like maybe the mechanism it practically may not work, but I think that, I mean, this is the segment where we're just kind of pontificating, so we'll let that pass, right? But I think that makes a lot of sense. So then I guess when we're talking, the thing that we've gone over is using zero knowledge proofs to find that you're a member of a tribe. And then before that, using zero knowledge proofs to authenticate. Some of this seems like it would be helpful in our metaverse conversation, where we talked about room-based computing, where you don't even own the devices that you're using. And so if you could have the same mechanism where your love match dings on the street, then you could conceivably authenticate yourself against any number of devices that are in the room, and this time you don't even have to divulge like what your passwords are,
Hmm.
and you would be able to move and use computing devices in public spaces without leaking your credentials. And so that might be an interesting future that would result from zero knowledge proofs.
Yeah, totally. Yeah, as we go into this metaverse, again, like I mentioned, there are going to be things that you don't want to be divulged to the general public, but at the same time, they're going to be running on the rails of this blockchain, right?
Mhm.
And so dating is a great example. So you could have a decentralized Tinder, and that's great. That's a very interesting idea. But yeah, I don't want everybody to know by inspecting the blockchain, or they know my wallet address or whatever, or my public key, that I, liked this person, or I matched with this person, or I hooked up with this person. And so, yeah, I think that it makes sense that you want to maintain that separately, package that up privately, so that the interested parties are able to verify with each other, but a observer wouldn't be able to verify anything. So that goes back to the scenario that you mentioned of interactive proofs, right? So maybe
Mhm.
two people are able to verify with each other, but then you can't just take the transcript of that proof and then say, aha, I know something, right? So there's that case. And I think, yeah, I think that there are, lots of cases where, again, you want to be a voting member of a DAO, you want to submit your insurance claim to a,
Yeah.
collective DAO. You, at the same time, again, are part of various game economies. And so all of this, like, I think, needs to be tied together in some way. And it doesn't make sense, like we've been discussing, it doesn't make sense for every aspect of your life to be run under the same trustless, decentralized regime that the main chain provides. You want to be able to twiddle the knobs depending on the scenario, and at the same time maintain a complete record of all the things that pertain to you. And I
Yeah.
see that this all kind of gets tied together under this zero knowledge proof umbrella.
Yeah, actually, as we were talking through some of these scenarios, the theme that jumps out to me is the separation of computation from the data. Because right
Mm-hmm.
now, it's more or less impossible for us to operate on data. Uh, like the person that's operating on the data, running the computation, needs to have the data to operate on. Like it's really hard to separate that. And so as a result, we then store our data on centralized web app servers. Like the way that a lot of our computation is architected is because of that fact. um, but what zero knowledge proofs and perhaps like other cryptographic primitives allow us to do is to separate the computation from the data, in that you can deliver the app to me, I run the computation on the data that I hold locally, and then I just have to prove to you that I did the computation correctly, and then you just verify it, right? And so
Mm-hmm.
that might be a way for users to keep their data private but still use web apps and centralized services, because instead of the data that's being delivered from users to centralized app, it's the other way around, where the apps are being delivered to the users, kind of like in the days of desktop apps. But
Mm-hmm.
now it's a way to sync and network the distribution of the application without going through big box stores like Best Buy.
Yeah, yeah, that
Does
makes
that
sense.
does that make sense what I'm trying to say? Because like
Mm-hmm.
it, yeah, like the paradigm is always like, oh, if I want to use the service on the web, I have to go to that destination and then put all my info there, whether it's like posting YouTube videos or making posts on Twitter and whatnot. But like
Right.
these sort of cryptographic primitives like zero knowledge proofs, enables us to build systems that turn it around on its head, I think, in a very primitive way right now,
Mm-hmm.
where it's the apps that are being delivered and I still hold on to my data. And even if my data is on chain, it's either accessible because it's read but not controlled by anybody, or it's encrypted so that only I can see it, but it's still on chain. And so that's kind of a very different world for the users and for the engineers that have to build out all this stuff all over again, I guess.
Yeah.
Does that make sense? And so,
Yeah. No, yeah,
yeah,
it does.
go for it.
Well, so yeah, I think one thing that when you were sharing that I thought of is just the fact that right now the average person's data is collected by so many so-called trusted third parties,
Yeah.
and so the term that we were using in the sort of pre-show discussion of this was the term clearinghouse.
Yeah.
And so these are banks, credit bureaus, loan or mortgage originators. So those are the sort of financial aspects, but even things like ad networks. So if you have a two-sided marketplace where you have advertisers and you have users, you have somebody in the middle who basically is a trusted third party, for
Yeah.
example, Google or Facebook or Amazon,
Mm-hmm.
who says, I'm going to match these two people because I know something about the users and I know something about the advertisers.
Yeah.
And so this creates, again, this single point of failure, or maybe multiple points of failures, but basically you have these points of failures where you have these clearinghouses that only play the role of collecting data for the purpose of matching two adversarial parties.
Mm-hmm.
And I can see that zero knowledge proofs kind of flip the script in that they could allow parties to transact without having a person in the middle or an institution in the middle to whom they divulge all their data and get stored into a centralized database just for the sake of proving that they have the assets to buy a house,
Mm-hmm.
or that they have good credit to get a loan, or that they are interested in X, Y, and Z topics to get served an ad. All of this
Oh,
can
yeah.
sort of get like this middlemen can get sort of obliterated, and these two parties are able to transact with each other directly.
That's pretty interesting because DAOs are starting to do this sort of stuff where they're gathering assets. And so if they want to hide their assets to the public, or they just have to prove that they hold these things, and they would still be able to do the transaction between them using this. That's so you could, yeah, like you said, like it kind of gives you knobs to tweak in this design space for what you want to make public and private in a world where things are decentralized. Yeah. So I have more comments, but did you want to finish your thought?
No, yeah, I'm curious
Okay.
to hear.
Yeah, so I was thinking, not this is kind of the on the software level where it's decoupling the computation from the data. But the other thing is people are trying to commoditize the cloud, or the cloud commoditize the hardware that you're running on, but like you still have specific clouds. And so it's the Pied Piper dream that you can run any computation anywhere, right? And
Yeah.
so I think some people are trying to build parts of this thing right now. At least that's the sense that I get with things like IPFS, where you don't know exactly where your data is stored. Oh, IPFS is interplanetary file system. And basically it's a decentralized network of storage where you can pin a piece of data and it will get replicated in that decentralized network and be accessible from any one of those nodes. If your machine goes down for a little bit, that pins the data. It'll still live on the network for a little while so that your data won't ever go down. Of course, you have to come back up at some time, but it's a way to service your data. And so I see zero knowledge proofs as one more way where you can build out this sort of decentralized web so that it won't matter what hardware that you're running on also, but it won't matter which cloud that you're running on, because it's just a collection of nodes out there. You don't care where it's running or where it's running. You just know that it's running. And so it's just kind of, I guess it's in the same sense that lay people feel about the internet. They don't know where things are. They just know that it's running somewhere.
Yeah.
But we, as technologists and engineers, we know that there's like still an actual centralized entity that controls it. And so zero knowledge proofs enable us to build out architecture where we're not reliant on a single entity, such as a company or organization, to do the right thing or be a single point of failure for hackers to steal their data.
Yeah, that makes a lot of sense. I think I was reading a Twitter thread about some controversy about ad networks, and so there's this idea in ads that you're an advertiser and you want to display an ad somewhere, and basically ad networks can compete for your business.
Yeah.
And so Google can say, well, okay, I will charge you this much for this ad. Facebook can say, I will charge you this much for this ad. Amazon will say, I'll charge you this much to display this ad on my affiliative sites. And the controversy is that there was collusion between Google and Facebook. And so basically Google was providing basically not the most competitive bid, but basically they ran this exchange, and so they were able to take a greater share of their business than was fair because they charged higher prices than their competitors, but these parties were colluding.
Yeah, if you're a participant on a platform you control, it's really tempting to do things like this, right?
Yeah, exactly. And as an advertiser who's participating in this platform, under this traditional regime, you don't really have any transparency as to what's going on, right? So this only surfaced because of some legal action, some antitrust suit led by a government. Now, at the same time, how could you solve this? Well, you could solve this by having a completely open ad exchange. This was happening on chain. You could see, well, okay, this person submitted a bid, and this was the, all the bids, and so it resolved. The business went to the contract resolves to give the bid to the lowest bidder, et cetera, et cetera. There are a lot of reasons why you wouldn't want to do this in a ad exchange. For example, people don't want to reveal all the ad campaigns that they're running. They don't want to reveal the keywords for which they're competing and how much they're willing to pay.
Yeah.
There are, a lot of auction protocols rely on secrecy, price secrecy, right? So you don't necessarily know how much a particular keyword is valued by your competitor. This is the whole premise of an auction. And so, yeah, I can see that zero knowledge proofs allow multiple parties to compete in these exchanges, on a completely fair basis, and be able to verify that the competition was fair, while at the same time not knowing exactly the details of each transaction that was happening on the platform. And similarly, in this computation case that you're describing, and the case that where you have a workload that you want to run, but you want to run it on any variety of of competing providers. I don't know if this is exactly the direction you're going with this.
Yeah,
but
it was.
I could see that I am, some company that is, let's say I'm a company that is building a general purpose or generally intelligent AI, and I need to, somehow provision tons and tons of compute to train, GPT 9001. And so I don't necessarily want to, I want to fan this out to a variety of compute providers. I might not necessarily I might not necessarily want my competitors to know that it is me who is training this massive, machine learning model.
Yeah.
And at the same time, I also want to make sure that I'm getting the best price for this on this compute exchange without there being a trusted third party who is running this auction scheme. And so I can see that there are a variety of ways in which zero knowledge proofs can be used to facilitate this. And maybe even going back to the...
And so to be clear, what you're saying is that the zero knowledge proof is making sure that the exchange is fair, but like, does that mean that you're doing the auction is fair rather than the machine learning computation, right? Because
Yeah.
Right. To be clear, because we mentioned earlier that like right now zero knowledge proofs they can only prove relatively simple computation. Like you're not going to be able to do the machine learning stuff in the near future, is my understanding. And so to be clear, what you're talking about, so that our caller or our viewers aren't like calling us out on stuff, is that you're talking about the fairness of the exchange. Of the auction. Right.
Yes. Yeah. So it's potentially possible that in the same, if somehow I both want to, submit a bid for some work, and it turns out that also the work can be framed as a zero knowledge proof. Yeah, even better, right? Like, even better. Like you're truly living in the future. But like, I'm specifically talking about the fairness of exchanges.
Right. Yeah, I mean that's reminds me of when I was working at a company in crypto. One of the things that we looked at was coin market cap. And for those of you in crypto, coin market cap is an index of the prices of the aggregate prices of different cryptocurrency tokens across all the different exchanges that it tracks. One of the issues for coin market cap early on was that it wasn't clear exactly how they were doing the aggregation across the different exchanges, nor was it clear like whether the exchanges had a verified price. And so sometimes there was an incident where coin market cap adjusted their algorithm slightly, which resulted in a collective drop in one of the cryptocurrency coins, which then precipitated panic selling in a coin as a result. And so it reminded me of an instance where it would be really nice if you could go to coin market cap and it could give you a proof that the aggregation that they did was done in this way, because the conversion of the different cryptocurrency coins to the same unit currency is actually a little bit tricky. It, as an aside, it turns out it's a graph search problem, which surprised me when I was working on it. And so having that verification of how they did that conversion and then the subsequent aggregation does make a difference. And the exchanges themselves, when they provide the API for this data, it would also be nice if they provided proofs or at least a cryptographic hash that, this data comes from this set of data or something like that. But none of that actually exists, which surprises me a little given that the space they're in. But maybe it's because nobody has clamored for it because it's good enough. But I do know that early on, for coin market cap, there was a lot of side eyeing of the prices that they would give sometimes because of this very fact.
Yeah, and I think that, as a lot of these DeFi protocols mature and sort of decentralized finance starts to take over, many aspects of life, there are definitely cases where you want to be able to verify to your stakeholders that, hey, this protocol that I'm running is doing the right thing.
Yeah.
Because that's the whole advantage of these clearinghouses. So NASDAQ is basically a place where, or not NASDAQ, actually, NASDAQ is a completely electronic exchange. But yeah, actually, even NASDAQ or any stock exchange is a trusted place where transactions happen, and they run a database and they run all these systems to facilitate these transactions. And people pay them a lot of money because they are trusted. People know that if the prices that they list are accurate, that they're not manipulating, things willy-nilly. The whole value of those parties is the fact that they are doing the right thing, right? And right now, this is by fiat, right? So I actually don't know if NASDAQ is doing the right thing. Maybe they are, siphoning, small, micro cents.
Yeah, don't contribute to the conspiracy theories out there, I guess. But yeah, no, I think it's right because I mean, there's record low trust in institutions and like government institutions or like large institutions nowadays. But yeah, like what this points to beyond separating data from compute at the higher level is a way to build what's essentially like a public good or a public exchange without like a centralized authority, and be able to trust that it's doing the right thing. And like we've come up with all sorts of other ways to have a centralized authority police like an exchange or a marketplace, which like it would be a public good otherwise, but it isn't, because it was impossible to do that before. And now I think we have some of the building blocks that lets us do this sort of thing, because if you can imagine Craigslist as being a public good, like a non-profit of sorts, where people can exchange that sort of stuff instead of being run by a single company, that I think opens up a lot of possibilities and startups and business models, because it's just something that people can build on, just like a lot of people build many things on the internet, right? If you had to pay for the internet, I think we would have had a very different history. And so I can imagine if marketplaces were more of a public good like the internet is, then you would be able to see a lot of different kinds of businesses and startups as a result.
Yeah, I think, the metaverse, as we're calling it, is going to require a whole other set of authority and a whole other set of ways to trust parties. It's possible that zero knowledge proofs, among other building blocks, are going to allow people to transact without having a shared legal system, shared financial system, shared framework that we rely on, and instead be able to transact with each other by directly verifying that they've done the right thing.
Yeah, it's a way for people to do stuff together without knowing each other. And we've made up different organizations to facilitate this, from your local HOA to companies and to governments. And I guess this is yet another way. And I guess this is the point at which I feel like our optimism has reached the stars. Like, I don't have anything else to add at this point. Do you?
No, I mean, I am happily in a committed relationship, but I think that I hope my children in the future are, if they have a crush, at school and they are, hesitant to share their feelings, I'm very, very optimistic that they're going to use zero knowledge proofs and they're able to save themselves from embarrassment and find love.
Exactly. All right. Yeah, I think out of all the things that we've talked about this, I think we've are well out of the stratosphere. Who knows whether these sort of things will come to pass, but I guess that's half the fun of the Technium. And so once again, this is Will.
And this is Sri.
And if you like what you hear, smash that like button. Shalaka subscribe, as Felicia Day would say. And I think we are going to be here next week talking about another new technical topic, and join us. That's all I got. You got anything else?
Yeah, I don't know. I mean, we're on all the podcast platforms. This is not just a YouTube channel. So yeah, listen to us on your commute. Listen to us while you're riding a spaceship.
Right.
On Blue Origin.
Nobody commutes anymore.
That's right. Yeah. Only to space.
Right. Only to space. Only to space. All right. Once again, this is Will and
Sri.
And we'll see you next week. Take care.
Bye.